School library has 3 books by Dickens, 4 books by Blyton, and 2 books by Porter. And find a number of ways of arranging the books on the shelf if the books written by the same author are indistinguishable. So this actually means that the books written by the same author, we can sort of consider them as an identical case. They're identical items, so they are non-distinct. So what we do is, right, the number of ways written by the same author is indistinguishable. So for part 1, right, actually there's a total of, you can see 3, 4, there's a total of 9 books. And the number of ways of arranging them, considering that all books written by Dickens are the same, right, that means we have 3 identical items. We need to divide by 3 factorial, right? And for Blyton, 4 identical items, so divide by 4 factorial. For Porter is 2 books, so 2 factorial. So the number of ways is just 1260 ways, right? So this is for part 1, the number of books written by the same author, 1260 ways. Okay. Now for part 2, right, the books written by the same author are distinguishable, and they must be together. So that means, right, let's say we see there's probably like Dickens 1, Dickens 2, Dickens 3. There's a Blyton 1, Blyton 2, Blyton 3, Blyton 4, and then there's a Porter 1, Porter 2, and they must be together. So what we do is we consider them as one bundle. We consider it as one bundle, 2 bundle, 3 bundles. How many ways can we arrange them? So you can see by arranging these 3 units, right, the number of ways for me to arrange them is 3 factorial. Above all, the number of ways to arrange the Dickens book is 3 factorial. The number of ways for me to arrange the Blyton books, 4 factorial. The number of ways for me to arrange the Porter books, 2 factorial, right? So this is like the permutation within the permutation, right? I permute the books within themselves, the unit. So my final answer will just be 3 factorial multiplied by 3 factorial multiplied by 4 factorial multiplied by 2 factorial to give me a total of 1728 ways, right? Because I need to consider I shift around the books, and as well as the books permute among themselves. Okay, total number of ways. Next up, find the total books written by the same author are distinguishable, and all 3 books by Dickens must be separated. Alright, all 3 books written by Dickens must be separated. So this becomes like a slotting problem. So if we think about it, there are a total of maybe 9 books. There are a total of 9 books. Right, so taking away the 3 Dickens books, right, we have about 6 books and another 6 books left. 6 other books, right? So these 6 other books, if we were to arrange, what we're going to do is we're going to arrange them side by side first. So maybe book 1, book 2, book 3, book 4, book 5, book 6, and then if you observe, right, I want to make sure that Dickens books are not together. So that means between each of them there must at least be 1 book. So you can see it. The number of ways you can slot in the Dickens books are 1, 2, 3, 4, 5, 6, 7. Out of these 7, I'm going to choose 3 of them to be slot in the Dickens books. Above all, these 3 can also, the order is important, they can arrange among themselves. So it's a 7 choose 3, 3 factorial. Or you can just say it's 7 permute 3. And what about the 6 books? Among themselves, these 6 books, right, what can they do? They can also, right, because they are distinguishable, they can also arrange themselves in how many ways? 6 factorial ways, right? So my final answer comes out to be just 6 factorial, considering I arrange all the other 6 books, multiply by 7 choose 3 times 3 factorial, because I'm slotting, now there's 7 choose 3 factorial ways of slotting in the Dickens books. And my final answer comes out to be 151200 ways.